This is Polymorphism. My name is Chris Lee and my student number is S2248178878. For this video, we're going to go over a few different topics. Now, the first is going to be compile time polymorphism versus runtime polymorphism. So for those two terms, we have compile time, which refers to our code being converted into machine code. That's going to be our method overloading. And our method overloading would be having two methods with the same name, but a different list of parameters defined. And we know which one to call based on the parameters that they're passed or not passed. Runtime polymorphism refers to method overriding. And the general gist of that is in the parent class, we will have the virtual keyword on a method, and that will denote that derived classes are going to override the behavior of that method. And then in our derived classes, we will use the override keyword and define the new behavior there. We're going to cover covariance as well, which is going to give us the ability to sort of use a more specific derived class than otherwise expected to. So a situation where that would be relevant would be if we had a collection of more specific objects. So we had a list of ducks and we wanted to add them to a more generic list of, say, birds. That would be an example of covariance. For upcasting, typically this is more of an implicit type conversion, and we don't really do this ourselves often. And the idea is that we're going to be able to convert an instance of a derived class to a base class. Some of the drawbacks for that is that you will lose specificity and you'll only be able to access the methods of the base class that you've upcasted to. And then for downcasting, we are converting superclass references down to derived class or subclass references. And the idea there is it's going to give us access to the methods and stuff like that in the derived class. In any event, we'll launch our program. And the first thing that we're doing here is creating a list that's going to store bird objects. It's called birds. Now, the bird constructor doesn't actually have any behavior defined, so we are going to associate all the values manually. We have a name property defined in the bird class, and we're going to assign the string feathers to that. So we'll come over here and we will set that property. We'll move down here. We'll create an instance of the duck class called duck1. Now, duck actually inherits from bird. It also has, well, it has no constructor, and the bird one has no behavior in the constructor. So it's going to move through the constructor for the bird class. It's not going to do anything, and we'll assign these values manually. The name property as well is inherited in the derived duck class, so that's going to go back into the bird class again and set it from there. The next two properties, size and kind, they are defined in the derived class. So we'll go in there to set those. We're going to create a second instance object as well called duck2 and do the same. Now for our birds list, we are going to add bird1, and we're also going to add duck1. Now duck1 has a base class reference, so as you can see in the comment here, the list of birds can hold any object of type bird. So that's one example of our polymorphism. I think that's the subtype polymorphism or something or other. This is just behavior to print out the list of birds in the birds list. So we're going to skip over that. Now for our covariance, again, this is going to be using more specific derived classes than expected. So for our example here, we are creating a list called ducks to add, and this is going to store duck objects. And in it, we're going to pass the two objects that we've already set up earlier, initialized rather. So that's duck1 and duck2. Now down here we have IEnumerable, and this is our read-only interface. And the idea here is that we are going to be able to add sort of our specific objects here alongside our more general ones. So in essence, we're going to treat ducks to add, which is our list of duck objects, as bird objects, and that's going to be stored in upcast ducks. So the IEnumerable in the end will store a collection of bird objects. We'll move down here and we will create another list called birds2. Now this is expecting bird objects again. So we'll initialize our first element in this list, and it will be called feather2. So we'll come back over here. The constructor has no behavior. We only want to go to the name property, set that. Now we are using a method called addRange, and the idea here is that we're adding multiple elements at once. So we'll add those two, we'll add duck1 and duck2, and remember we upcasted those, so they're currently being treated as bird objects there. And then we'll move into another loop just to print them out. We can actually see if we come down here into our watch list, we have birds2, which is our list. And our first element in there is of the bird class, and then we're treating the 2 duck instance objects as birds, or bird objects, I should say. We'll move on from that anyway. Now for our downcasting example, I've sort of tweaked this a little bit, just because I found it a little bit confusing when I was first playing around with it. So this type of setup is not really a typical approach. But in any event, we're creating a bird reference called testbird, and that's going to point to a duck object. Now, at this point in time, we're going to associate the name to the string testbird. And yeah, what I was going to say was at this point in time, we only have access to the fly method from the testbird class. So that's in here. We're not actually using the virtual or override keywords because I didn't want the overridden behavior in duck to take over. I wanted to be able to see the difference as we were downcasting. So we're going to call the fly method from the bird class here. It's going to print flat, flat, flat. We'll return down here. And this is where we are downcasting the bird reference back to a duck reference. So we're creating another reference called test duck of the duck class. And we're casting test bird to that. And then when we call the test duck.fly method, we'll come down here and we have the other method here with the overridden behavior, if you will. And that's just going to say method hiding fly. Now it says that because this is not method overriding or anything like that. This is using the new keyword, and we're defining new behavior in there. So this is called method hiding. And like I sort of touched on before, if we used override like I would have for method overriding, both the testbird and test duck objects would have just used the overridden behavior, and that's not really what I wanted. Thank you.